Hi, welcome to another video on my Raspberry Pi with electronics. Last time I replaced the connection of this motor with an LED, which not quite surprisingly worked immediately, mostly due to the very low voltage that the LED needs to burn. It doesn't burn now, but if I turn on the voltage, or try to anyway, then I would be very happy if something did work. So let's keep trying. There you go. It does work. And if I turn away the light, you can see that this LED is burning quite brightly, this a little bit less, and this even lesser. The point is that and let me put the motor onto it. The motor doesn't run and the LED stops burning. I remove the motor and it does start, and then I'm talking about both LEDs. So, as I said last time, I am going to change the setup of this, and I will ignore for now this part of the circuit. So, in order to do that, what I want to do is to put the pulse width modulation directly here. So, how can I best do that? This wire is the pulse width modulation. I am taking it away. And now let's see how I can do this. This is the pulse width modulation, and the software is running on 1024. So, is there any change? No, there isn't. So I'll reduce the voltage. Is there any change? Well, the LEDs here stop working. This is still running. And you can see the difference with the LEDs. So I probably need to not only reroute the pulse width modulation, which is here, but also need to do something with the power. What I also need to do, because of the schematics that I showed last time, is remove the transistor. So I'll do it a little bit different. I will put a kind of circuit here and have it separated from everything else. So what do I need? I need an LED. I need a resistor. And I think, yeah, well, the pulse width modulation I do need too. So let's start. So I will remove this motor for now. Using this part, I connect one resistor to the mass, then another resistor in series to double the resistance to 340 ohms. Then an LED and pulse width modulation. And you can see that it is burning now. It is not blinking but burning. So what happens? By the way, this is still 1024 in pulse width modulation value. So let's take the multimeter again. Put it to frequency. There we go. And try to measure. One probe to mass and one probe here. That is about 30 kilohertz. So I change it to 0. And you see that the value is completely different. The LED hardly burns, as you can, or doesn't burn at all. I don't think it burns right now. I'm measuring it. It's totally no frequency at all. So I put in the value 100. On kilohertz. Or 1, like not measurable. I put in the value 200. Is it doing anything? Yes, quite faintly. Quite faintly, it does something. But can I measure something? I think this is next to an error. Let's go to 500, which is about half the scale. Wait, I'm measuring it wrong. I switched the probes without noticing. Back to 100. But there's still no change. So 200. Now it clearly burns. 500. $1,024. And this is strange. so I go to 800, 224 less. And yet again nothing. I find it strange. So let's go to 1020. 2 kilohertz. So apparently the frequency under 1000, let's say 1999, goes to nothing. Let's measure again. This is 1999. Which I find it strange. I'll have to see what's happening. Okay, so let me focus on the pulse width modulation values around 1000. I set the value to 1050. Measuring from here to here, it says 12, almost 13 kilohertz. Here it's 5 kilohertz. Let me pull it up a little. Okay, same. Here it is 12. So here it is 12. Here it drops to 6. Still kilohertz. Yeah, no surprise there. So let me go to 995. $17. 15. Around 16. Go to 1001. Around 14 kilohertz and around 12 kilohertz. So there's a 2 kilohertz difference after the before the resistor and after the resistor. The point is, of course, when I go to way below 1000, 500 in this time, in this case, I go no value. Up to 800. See, and that is also strange. Am I measuring wrong the whole time then? What if I use only the mass probe? Five kilohertz. And the plus probe 15 kilohertz. And this is strange as well. Okay, interesting. Let me find out how if I need to use 1 or 2 probes for frequency measuring. That's an interesting thought. Never occurred to me before. Let's do it. Okay, so according to online documentation, I am doing it the correct way. It doesn't explain, by the way, why I now get values here and they disappear. And according to the documentation, I should put anywhere black first, then red, and remove them in the other way. However, this clearly shows nothing. This leaves me at there's a big question. What is the correct frequency? If any. Because now I am at, let me probe here at the LED. Okay, I'll do it this way. Just at the LED. Now it says nothing. I go to 1000. I mean 1000. Measuring, and it says 5 kilohertz. Not exactly then. So even that is not quite sure. Let me do something else. I'm going to test the voltage. I put the voltage to 20 volts DC. Mass 0.66. That's twice as much. 3 times, actually 5 times as much. 6 times 5 is 30. And here you can clearly see it's 5, and here you can clearly see it's 3. So factor 5 difference. Anyway, we're here for frequency measuring. So this is quite a difference. Would it matter if I change the red LED for a green one? And then I take this green LED if it works, that is. Apparently not. No. Alright. Another green LED then. trying to put it in the right way from the beginning. Oops. Right. So the other one is broken. Measuring. Nothing. Okay, is there a conclusion? Not quite sure. On the other hand, I need a low frequency for this type of motor. Maximum, minimum is 40 Hz, maximum is 120 Hz. So let me check for that. So let me go for 120 Hz. Not even close. Go to 500. So what about adding a resistor? Oops. Adding a resistor will change the circuit, of course, a bit. So let me put it like this and like this, and then turning this one like here. 3 resistors in series, making 400 ohms, about that. Let me check. This .7 kilo ohms, which is correct. So is this 700 ohms? Let me check further. Okay. How much is this one? 100. Yeah, 186 ohms. This one is 700 ohms. This one 700 ohms. They are not the same. Let me check, although outside the scope of this video. $186 about that, and this one about the same. This one again 700 ohms. This one 700 ohms. These are clearly, very clearly different resistors. So going back to frequency. So now I have 700 plus 700 is 1K4. 1K5 Hertz, 1K5 And what is the frequency? Well, here nothing has changed. This is says at a value of 500 pulse modulation, 12 kilohertz. If I change it to 2024, it's exactly the same, and that can't be. It should be different frequencies altogether. This is about 4 kilohertz. And 3 kilohertz, but way too high for the values I want. I'm riddled. Really riddled. Okay, one last attempt for now. I'm going to remove this resistor. And then like this one. Right here. So to avoid any measurement mistakes, I'm going once again measure the resistances. Not voltages, the resistance. Setting at 2K. So this one, it would be very nice if I get the value. Nothing, and okay. Time for a different multimeter. Although I can't measure frequencies then, so that is a downside. But voltages, yeah. I have to take and connect it. Put it to how many ohms? 1 kilo ohm. No, I put 2 ohms. Then I have this multimeter again set at let me get the probe ready, and measuring them right here. And this is a nice response. What does this mean? Go beyond the scale. So I'm going to change it to kilo ohms. 1 kilo ohm. What does it do? Um, 1.5, 1500. This is 1500 ohms. This one is about the same, 1500 ohms. So apparently something is not quite alright with the other multimeter when it comes to resistance. One more check. This should be 3000 ohms. Kilo ohm. Is it? Not quite sure. Changing the value to 10k. I'm not really sure about my measurements. Anyway, this shows that either the program is not okay, which I doubt, or my measurements are incorrect, which is more likely, for one reason or another. So this is to be continued. For now, thank you for watching. If you like my videos, please subscribe. And please consider to to not block advertisements to support my blog. And visit my website every now and then for more projects. To be continued.